All right, for question number 5, we have to solve the equation log base 3 of x minus 4 equals 2. And so what we're going to do is the opposite of log form is exponential form. So I'm going to say 3 to this exponent equals 3 to that exponent. And so these cancel, and I get x minus 4 equals 9. And then I can go ahead and add 4 over, and I get x equals 13. Now there's another way we could do this exact same problem. We could graph it. So I could say math log base 3 of x minus 4 equals 2, and I want to see where these two lines cross each other. Now the x values that I'm expecting to see are anywhere between 5 and 13, so that means I need my x values to go up to 13. My y value that I'm looking for it to cross at is 2, and so that means that on my window my y's need to go at least to 2. So there's the log curve, there's the y value of 2, and if I find the intersection, again I don't have to be right on it, the intersection is at x equals, well I got rid of it, but x equals 13 was the answer for that one. All right, a man is standing on level ground 50 feet away from the wall of a building. So here is the building, here is the man, he is 50 feet away. He looks up at the window of the building, so let's say here's a window. And it says the angle of elevation to the bottom of the window. Dang it. The angle of elevation to the bottom of the window is 28.5. Then he looks up to the top of the building. The angle of elevation to the top of the building is 35. So here's him looking to the top of the building. And then this right here is 35. Okay. So what's happening here is we have two triangles, and they want to know the approximate distance between the bottom of the window and the top of the building. All right, so if we said that this side of the triangle that I drew in pencil that has that 28.5 degree angle is x, and then we could say that this side of the red triangle is y, then the answer that we're looking for from the bottom of the window to the top of the building would be y minus x. So that's what we're looking for to get our final answer. Okay, so I have two right triangles I can draw to solve this information. 28.5, 50x, and then over here, 35y, and 50. Okay, so this is a right triangle, so this is a SOHCAHTOA problem. And both of these, if this is my angle, I have opposite over adjacent, which is tan. So for the first triangle, I'm going to say tan of 28.5 equals opposite over adjacent, and tan of 35 equals opposite over adjacent. Okay, so in both of these problems, I just need to take the 50 and multiply it to the other side. All right, so y is going to be, I'm going to move the 50 to the other side, 50 tan 35. I do need to make sure I'm in degrees. I am, okay. Tan 50, 35, that's my y, minus 50 tan. I think I said tan 50. Anyway, 50 times tan 35. And then my x is what I'm subtracting off, so I need to subtract off 50 tan 28.5. And so the distance from the bottom of the window to the top of the building would be 7.86 or 7.9. Okay. Triangle WXY has the following properties. the angle at vertex W is 14 degrees, and the angle at vertex X is obtuse. Okay. The side opposite of vertex W has a length of 7. The side opposite vertex X has a length of 9. So it's a triangle problem. The information they gave us is angle side side. And if you guys recall, angle side side is law of sines. And it is the ambiguous case, which means that we draw two triangles. I did not leave myself very much space. So I'm drawing the exact same triangle 2 times. And then for me to set up the law of sines, I need to go ahead and write the information I have. So I'm going to say sine of 14 divided by 7 equals sine of x over 9. Okay, so for me to solve this, I'm going to do 9 times sine of 14 divided by 7. So that equals sine x. I was just cross multiplying. So I need to do sine inverse of that decimal. And that gives me that x is 18.122. But they told us that x is obtuse. So that is just the x value in the first triangle, and they have given us enough information to know that the first triangle from the ambiguous case is not the one that we're looking at. So if you guys recall, to get that same angle in the second triangle, we need to do 180 minus that angle from the first triangle. So angle x is actually 161.878 degrees. So now we have found angle x. And so we know that we're talking about this triangle. Now we have to look at what the question is actually asking for. They want to know the approximate length of the side opposite of vertex y. So they want to know what side y is. So I'm going to go ahead and solve for angle y. I have 180 minus the x angle that I just got minus 14. So angle y is 4.122 degrees. I'm going to go ahead and store that as y. And so now if I want to find side y, I'm going to go ahead and use the law of sines again. I don't have space, so I'm not going to write it again. So I'm going to have sine 14 over 7 equals sine of y, the y that I stored, divided by side y. So I have sine of angle y multiplied by 7 divided by sine of 14. So side y is 2.080. And it's B. All right, number 8. Consider the two functions. How should the graph be shifted to produce the graph of G? Now, the only difference between these two, notice that vertical stretch is the same, the horizontal compression of 1/2 is the same, right? It says 2, but I know it's the opposite of what I think. And the 4 is the same. So the only difference here is that minus pi halves. And most students would get this wrong, and they would say it was right pi halves. They would be wrong. So if you guys recall, whenever we see problems like g of x, we have to factor the inside of the parentheses. So that's really 2 times x. If I take the pi halves and I divide out 2, I get pi fourths. So now I can compare the original and the new one. The 3's are the same, the 2's are the same, the 4's are the same. The difference is the pi fourths. This graph is shifting from f by moving to the right pi fourths.